Salt and speaker.
We conducted a similar experiment to the one of the violin bow, but with speakers instead. Some parts of the plate are moving a lot, while other parts are standing still. The salt is bounced away from the parts which are moving a lot, called the antinodes, and is left in the places where the plate is not moving at all, called the nodes. The difference between each structure or line is the wavelength of the sound wave at the given frequency.
Salt and violin bow.
We use salt and vibrations to visualize areas of compression and refractions in sound waves. However, we used a sheet of metal and the violin bow to do so. Vibrated due to the sound waves traveling through it. The salt bounced around and settled at nodal points, the points of zero amplitude, meaning the particles at those points were not moved by waves. Indicate that sound waves have moved the salt away. Additionally, the areas where the salt collected are rarefactions, meaning they are points of low pressure, and the areas where their salt did not collect are points of compression, which is why the salt was moved away from these points.
Salt and PVC tube.
Tube exit from one side using a balloon and placed salt on top of it. When we made noise on one end, the salt moved in distinct patterns depending on the frequency of the sound produced. This is due to the movement of the sound wave that attempts to exit the PVC tube, and because it cannot do so, it will hit different spots of the balloon. As you can observe, the places on the balloon when there is little to no salt are the places where there is more pressure. These are called areas of compression. This pressure is created by the sound waves and push the salt outwards. As a result, there is more salt in the rarefactions due to the lesser pressure in these areas. The distances between each of these rarefactions is the wavelength. When we created sounds of higher frequency, the wavelengths would be smaller. Therefore, the space between the rarefactions would be smaller. It is important to note that the salt bounces on the balloon until settling at nodal points. That is how it creates the patterns.
Cornstarch and speaker.
In the mixture of cornstarch, cymatics can be seen quite simply. When sound is emitted from the speaker, it provides enough force to solidify the mixture at certain places, these being at points of compression and rarefactions. The points where the mixture remains liquid and flat are rarefactions. As seen in the demonstration, the nodes and antinodes are easily spotted. The points that are unchanging and remain liquid are the nodes, and the rising slopes are the antinodes. It is also important to note that this didn't work with higher frequencies because of the force of the waves. Even though at higher frequencies the waves are more, the force of each is much less, which is why this experiment was conducted at lower frequencies, such as 60 Hz.
Water and speaker.
Another example of cymatics we used was making sound using a speaker and demonstrating how sound waves travel through water. We placed a small plate over the speakers and started to play music and fixed frequencies. At the beginning, the sound waves from the speakers are hitting the plate in the center, causing water waves to form. As they expand from the center, the waves hit the limits of the plate and bounce back, creating constructive interference, which means that the overall amplitude will increase and we will see higher waves. Also, standing waves are produced as a result of the repeated interference of the waves with identical frequency while moving in opposite directions along the same medium. All standing wave patterns consist of nodes and antinodes. Also, because they bounce off from the edges, the pattern shown at the beginning is lost and the water waves bounce into each other randomly, creating constructive interference or destructive interference, depending on how the waves hit each other. It is important to note that the red color that we introduced was purely aesthetic and has no addition to the explanation of cymatics.